If you are struggling with solving physics problems related to Newton's laws of motion, this video will be very helpful for you. So while solving physics problem, especially related to forces, there are few basic strategies, basic steps that you must follow to solve the problem. So I'm writing here the basic steps you must follow to solve the physics problems related to the forces. So first thing to solve the physics problem is you have to draw a free body diagram. Okay, free body diagram. So after drawing free body diagram of the situation given, set axis, that is coordinate axis. Okay, so you have to set the axis, x-axis, y-axis, whatever the axis is there, we have to set axis. Okay, third one is write down Newton's equation. Write down Newton's second law of motion. Okay, that is the equation of forces along the axis, x-axis and y-axis. Okay, and the next step is work with one axis at a time. Don't mix of all the axes at the same time. You cannot work with the different axes at one time. And final step is solve for the target variable. Okay, if you follow the instructions in this video and use these steps, there are 5 steps, 1 2 3 4 and 5 steps, right? 1 2 3 4 5 steps. These 5 steps, I'm sure you can easily deal with any kinds of physics problems that are related to Newton's second law of motion or Newton's laws of motion. Okay, so draw a free diagram. I will show you how to draw a free body diagram very clearly. You will understand, you will be able to figure out how to draw a free body diagram for the particular situation given in the problem. Then once you are able to draw a free body diagram, set the coordinate axis. Setting coordinate axis is very important. Otherwise you will be misguided, forces will be mixed up, which lead to the wrong answer. Okay, so third one is write down the Newton's second law of motion. You can write down the equation for x-axis and equation for y-axis. Okay, and then while solving the problem, when getting the target variable, you have to work with a single axis. For example, if you are dealing with x-axis, don't mix with y-axis or some other axis. Okay, and finally, once you have equation for the particular axis, you can solve for particular target variable that you are gonna to find, that is asked in the question, right? Okay, so let's read this problem first. A 2 kg university physics book sits on the floor. The book is pulled by a string that make an angle of 30 degree with horizontal surface. That is the given situation. Let me draw a free body diagram for this situation. Okay, so let us say this is a physics book. Even you can put for like a single dot to represent a physics book. For instance, let's make like a something like a book like this. So this book university physics book sits on the surface. So let me make a surface for instance, and this book is attached with a string uh, which makes an angle 30 degrees. So I'm putting a string right here, and this string is making 30 degree with horizontal, right? This is 30 degree angle. The tension in this string is 5 Newton. So I will say the tension in the string like T. Okay, so this is the kind of force. Okay, this is a kind of force, tension force. Draw a free body diagram and find a horizontal acceleration and a normal force. Ignore air resistance. Air resistance can be ignored, and we can also ignore friction. Okay, rather than air, let's say friction is better. Okay, ignore friction, frictional resistance or frictional force, whatever you can say. So what is the normal force? When we are talking about the forces in the mechanics and physics, there are four kinds of normal forces, common forces. For example, normal force is the force when you place an object on certain surface. This is the surface. The normal force will always act upward, that is normal to, perpendicular to the surface, right? This is said to be normal force and denoted by N. This is one kind of force. This is the contact force. And the second force is the tension force. Look at here. This is the string right here attached to this book, and a force acting in this string is T, that we call tension, which is also a contact force. Okay, that is second kind of force. The another force is the frictional force that we are not considering for this time because we are ignoring frictional force. Okay, so other kinds of force that we are dealing with in these kinds of problem is the weight. That is, because of the gravity, there is the weight that we denote by W and given by mg, where m is mass of an object and z is acceleration due to gravity. Okay, so these are the kinds of force we are dealing with. Okay, so for this question, we are ignoring frictional force. If you ignore frictional force, there are three forces acting in this system. That is normal force, tension force, and weight mg, that is the gravity. Okay, these are the kinds of forces that we have to work with. This tension force is acting in this direction and the normal force is acting upward. Let's make a line like this one, which is the normal force, right? And mg will act downward. This is the downward. W is equal to mg. Get here, this is the free body diagram. Okay, so first thing you have to work out, you have to draw is the free body diagram, and we draw the free body diagram for the given situation, right? Now second thing is set coordinate axis. This is the force tension, the tension force, this is the normal force, this is the weight. If there is friction, we can apply the friction right here, but in this case friction is absent, we consider that. So ignore that, and then let me set axis. This is the y-axis and this is x-axis. You can put aside like this to match with the problem, or you can just set it here. This is the x-axis and this is the y-axis, right? You can do either one is okay. So This is called pre-body diagram. You can simply put the dot for book, and you can remove even this surface on which book is kept, that is the flower, and simply uh, put the dot for the book or any object, given object, or just simply draw like this. Okay, so this is the pre-body diagram with setting coordinate axis. Okay, we set coordinate axis x-axis along the floor surface, and perpendicular surface to the floor is the y-axis for this case. Okay, so we completed two steps. First is drawing pre-body diagram, and the second is setting coordinate axis. What is the next step to do? The next step is use the diagram to write Newton's second law equations along axis, okay, x-axis and y-axis. Let us write down the equations. For example, along x-axis. Now let's work for x-axis. Okay, x-axis. So for x-axis, let me write down the equation. What are the forces? So the only force responsible for the motion along x-axis is because of tension, right? There is no other force acting this particle, this book, and this tension force is acting with 30-degree with x-axis. So we need to split this vector into its component, that is x component and y component. So what is the x component? X component is t cos of theta, right? So theta is the angle here. If we symbolize, the angle as a theta, I can write down this way. So actually t is given somewhere here in the problem, which is uh, 5 Newton, right? And theta is 30-degree given here. Okay, so for x-axis, let me write down the force, the sum of the forces along the x-axis, x forces, is equal to t tension, right, cos of the theta, and this is the only force that causes acceleration, that is called x acceleration, right? So this is the one equation. Let me write down another equation. So let me again write down the y component of this one. So you know the component, right? If you complete this triangle, simply take the sine of this theta, that gives you t cos theta for this side, and t cosine theta, t sine of theta will be acting upward. So this is the component of this tension force along y-axis. This is acting vertical, right? T sine theta, and this one is acting horizontal side. So for this side, normal force is there. I'm working with y-axis. Let me write it down here, acting with y-axis. Okay, working with y-axis. So n is acting upward, that is positive y-axis, so I'm taking positive, and this t sine theta is also positive, so this is t sine of theta, and direction of w, this is the zero line, right? You know the coordinate axis, below is the negative sign, so negative w is equal to 0. Okay, so our purpose is to find the target variable that is not given, that are unknown quantities. So first thing in the question is what is the acceleration, that is horizontal acceleration, and the second one is normal force. So when you solve this equation, you can find acceleration, because you can see the acceleration term in first equation, this equation, and normal force right here. Okay, so let me first solve for this one acceleration. If I solve for acceleration, acceleration will be t cos of theta divided by m. Let me plug in all the values. T is given here, which is 5 Newton multiplied by cos of 30 degree divided by mass is given. Mass of this object is uh, 2 kilogram, which is the book, right? If you calculate this value, your acceleration is something like 2.2 meter per second square. Okay, so acceleration, let me write down here, acceleration is 2.2 meter per second square. Okay, we are done, we get it. That is the acceleration of that book when somebody pulled by a force of 5 Newton through this string. Okay, now let me solve the second equation so that I can get the value of the normal force. I don't know what it is right now. Based on the given information, I can solve it out. Okay, t sine theta. What is W? W is simply mg minus t sine of theta, right? So if I insert all the values, mass is 2, and what is g? G is acceleration due to gravity, and negative 5 Newton is 3, and sine 30 degree is already there. This gives you 19.6 minus 2.5, right? This will finally give you something like 17.1 Newton. That is the value of normal force. So your value of normal force is 17.1 Newton, and acceleration is ax is equal to this much. Okay, so from this problem you are able to find acceleration and normal force. Okay, so this is one kind of problem. Let me do some other problem so that you will understand much detail. Okay, so this is the second kind of problem, just different from the previous one, but you can apply same approach. Okay, let me read this question. A man pulls a box placed on a ramp. Ramp is an inclined plane. The box has a mass of 20 kg and ramp is 30 degree inclined with horizontal. The force applied in the box is 50 Newton at 10 degree above horizontal. Find the acceleration of the box. Okay, let me draw a diagram for this situation. Let me draw it. So this is the inclined plane on which the box is kept. Okay, and then let me complete this one. This is the complete picture. Let me put diagram the box here, and mg will be acting downward, right? So this is the mg that we can call w, right? Gravity. So you are now more experienced than before. That's why I do little bit quicker. And splitting into component, here is the angle right now is 30 degree, and this component, the splitting into component, this is the negative mg sine of theta, right? This mg is acting downward. You can split into components, x and y component. This component will be mg cos of theta, right? And a boy is applying force to the box from here. This is the, I'm just splitting the force because of the gravity, right? Weight. So a boy is pushing this box or pulling from here with making 10 Newton. He's just pulling something like this, and he's making like 10 degree with the horizontal, right? And this is the horizontal. This is the horizontal, right? Okay. So let me set axis for this one. I am setting axis. This is the x-axis, which is parallel to this inclined plane. Okay. And y-axis, let me set it here. Y-axis is perpendicular to this surface, and the normal force will be this one. Okay. This is the normal force. So what is this angle right here? This is the 20 degree, because this is 30 degree. This whole will be 30 degree, and this angle will be how much? 20 degree. Okay. So this is the free body diagram for the situation given here. We have an inclined plane, a box here, mg is acting downward, split into its component. Normal force will be perpendicular, right? Normal force, remember one thing, normal force is not just vertical. Normal force is perpendicular to the surface on which you put an object. If you put an object somewhere in this surface, vertical surface, normal force could be horizontal, right? Direction could be horizontal. It is the perpendicular with the surface, not always facing upward, okay? That is the very, very important point to be remembered. So this is the normal force facing upward. So this is negative. I wrote down negative because this is the negative x-axis. I set axis. This is the positive y-axis. Down will be the negative y-axis, and this is the x-axis. Okay. So now what is the force applied by the boy? Let us say this force applied by boy, this is the force applied by boy, F, right? What is this component? That is the base, right? If you complete the right angle here, so this is the right angle to triangle, this is 20 degree, this base is like F cos theta, right? Component along x-axis. X-axis means along this surface, right? F cos theta. What is the vertical vertical one? The along y-axis, along this axis, right? In this direction, the force is F sine 20 degree, right? This is the 20 degree theta right here. F sine 20 degree, and this one is also cos 20 degree. Okay, to differentiate from this angle, so let me write down that way. Okay, and let me erase this one so that it will be easier. Okay, so this is the x-axis. X-axis is along the inclined plane, and perpendicular to this inclined plane is the y-axis. Okay, so we draw a free body diagram and we set the coordinate. Third and most important thing is write down Newton's equations. Okay, so now work for x-axis. X-axis. What are the forces acting along x-axis? One is this force starting from here. Look at here, mg sine theta. What else is there? Plus F cos, let me directly write down 20 degree. Okay, so this is the another force. This is acting positive direction, so write down as it is. And this one will be equal to max because it is creating acceleration along x-axis, right? This is the one. And the second one equation, that is the normal force along y-axis, is y-axis. Let me write it down again. And one is the normal force, straightforward, minus mg cos theta. Theta is 30 degree for this one. And again minus, this is negative y-axis, right? F sine 20 degree. F sine 20 degree is equal to may. That is the y acceleration, right? But remember, this particle, this box do not have any acceleration, any kinds of motion along y-axis. This box is not flying. This is not going up and down in this direction. That's why acceleration is 0 here, right? So this is 0. Okay, this is 0. Now we can solve the problem. Let me erase everything from here so that we don't need any more. We will have more space. Yeah, just maybe you can draw you can draw I erased this one, so let me draw it again just to show you. This was mg. Okay, I already explained everything, so I wanted to write down equation directly. And if I write down forces here, this force was mg cos theta, right? Right here was negative mg sin theta. Upward was normal force. This direction was tension, right? So the force cos 20 degree, and the downward direction was f sine 20 degree, right? So we have two equations. So first equation was along the x-axis, and it was minus mg sine of theta plus f cos 20 degree is equal to max, right? Our goal is to find a x acceleration. So that's why let me put values from the equation. What is the mass? Mass is 20 kg, right? It's right here, which is 20 kg. Negative 20 kg multiplied by 9.8, which is z. Then sine 30 degree plus, what is the force? Force is 50 Newton. Then cos of 20 degree is equal to, what is the mass again? 20, and max. Not a m. We put the value for ax, right? So this is, from there you can calculate ax. If you put all these things into calculator and this one also, you will get something like ax is equal to negative 51.01 divided by 20, right? This gives you 2.55 meter per second square. Okay, so this is the acceleration, and this is the negative. Why this is negative? This is negative because the boy who is pushing from here do not apply enough force to go upward because of the gravity. Even if boy is applying force, it is coming down towards the ground. Okay, so this is the deceleration along this ramp. Okay, if you have to calculate normal force, you can do that. We have second equation, right? But right now I'm not calculating here. You can do by yourself. Let me just write down again that equation, which was along y-axis, normal minus mz cos 30 degree minus f sine 20 degree is equal to 0, right? So if you don't know n, which is mz cos 30 degree minus f sine 20 degree, it will be plus other side, right? So let me put all the values into 9.8 into cos 30 degree plus f is 50 into sine 20 degree. Okay, so from here you can calculate value of the normal force acting upward. Okay, so in this way you can solve any physics problems related to Newton's laws by using free body diagram, writing equations along x-axis and y-axis, and solving for unknown variables. Okay, once you know all the other variables are given in an equation, you can easily find unknown variable. If there are two unknown variables, if you are able to set two equations, you can easily calculate those target variables. Okay,